Question. An elk walks 25 kilometers east, 53.13 degrees toward north, then walks 20 kilometers south, and then runs 15 kilometers west. The journey takes 12 hours. A. Calculate the elk's average velocity. B. Calculate the elk's average speed. C. Explain the difference in the two answers for the elk's average velocity and average speed. So this is the direction. This is north, also positive y direction. This is east, also positive x direction. This is south, also negative y direction. And this is west, also negative x direction. Now for vector delta D1, this is 25 kilometers east, 53.13 degrees toward north. For this vector, I draw the graph. So this direction is north, also positive y direction. And this direction is east, also positive x direction. The direction of vector delta D1 is east, 53.13 degrees toward north. So it should be here, like this. So this is vector delta D1. And this is vector delta D1y. This is vector delta D1x. And this angle is 53.13 degrees. Now from this graph, we can know the magnitude of the vector delta D1x equals the magnitude of vector delta D1 multiplied cosine 53.13 degrees, and this equals 25 multiplied cosine 53.13 degrees, and this equals 15 kilometers. So vector delta D1x is just 15 kilometers. It's positive because its direction is the positive x direction. Now we know the magnitude of vector delta D1y equals the magnitude of vector delta D1 multiply sine 53.13 degrees, and this equals 25 multiply sine 53.13 degrees, and this equals 20 kilometers. So we know vector delta D1y just equals 20 kilometers. It's positive because its direction is the positive y direction. Then, for vector delta D2, this vector is 20 kilometers direction south. I draw the graph. So this direction is the south, also negative y direction. And this is vector delta d2. From the graph, we can know that the vector delta d2y just equals the vector delta d2. Because vector delta d2 is parallel to the negative y direction, then this equals negative 20 kilometers. It's negative because its direction is the negative y direction. And similarly, for vector delta d3 equals 15 kilometers direction west. I draw the graph. So this is west direction and also negative x direction. And this is the vector delta d3. From the graph, we can know that the vector delta d3x just equals delta d3 vector and equals negative 15 kilometers. And from the information above, we can know that vector delta dtx equals vector delta d1x plus vector delta d3x and equals 15 kilometers plus negative 15 kilometers and equals 0 kilometers. Also, delta dty vector equals vector delta dyy plus vector delta d2y and equals 20 plus negative 20 also equals 0 kilometer. Then we know that the vector delta dt just equals 0. It's because delta dtx and delta dty are all 0. Then question A. The velocity, average velocity, just equals the total displacement delta dt over the time interval delta t and equals 0 over the time interval is 12 hours. And this equals 0 kilometer per hour. Then question B. For the average speed, we need to use the total distance divided by the time interval. The total distance delta dt equals the magnitude of delta d1 plus the magnitude of delta d2 plus the magnitude of delta d3. And this equals 25 plus 20 plus 15 and equals 60 kilometers. And the average velocity just equals the total distance divided by the time interval delta t and equals 60 over 12 and equals 5 kilometers per hour. Now question C. Question asks, explain the difference between the average velocity and average speed. The velocity and speed are two things. Velocity is a vector and speed is a scalar. And velocity has direction and magnitude. and speed only has the magnitude. To calculate the average velocity, we need to use the total displacement divided by the time interval. And for average speed, we need to use the total distance divided by the time interval. So they are completely two different things. So they are different. The answers for them are different. Yes, they are related. They have a relation, but they are different.